Okay, so we are here with our AP Stats class. Going to do our best to go over an investigative task problem. This one is from 2018, so students would have taken it last year. So students have just read the first page, and we're going to start talking about part A. Okay, so this is asking about a condition, and it's asking, is it reasonable to assume that this condition is met? That we would think that the distribution of p hat sub x, all right, which is a proportion, is approximately normal. Does anyone have any thoughts on how to answer this? Anyone? Any thoughts? Now this is from a very tiny part of, I think, chapter 16, maybe 17. I forgot the exact number. Probably 17, I think, now that I think about it. And one of the conditions when you think about going from a binomial distribution to normal is to think about your number of successes and your number of failures. All right, and it's something that we did when we did our one proportion z-test. Do you guys remember the large enough, what was it? The sample size assumption that we said it was large enough, and we checked that by doing the success failure condition where we did n times p and n times q. That's ultimately where all this is coming from. So what I want you to write, and so I made a smart notebook file to write here, what I'm going to write down is the answer. So it is reasonable. It is reasonable to assume that the distribution is approximately normal. The required condition is that there at least 10 successes and 10 failures in our sample. And if you read the problem, does anybody remember how many successes and failures there were? So 44 are defective, right? That's what Luis just said. Now what's weird about this is that those 44 defective would actually be considered what? Those are actually considered the successes. So in this case, there are 44 successes. And if you take that number away from 400, you get 356 failures. And you can see both of those numbers exceed 10. Okay, so I mean, this first part is definitely challenging. It required you to understand something about these conditions to go from binomial to thinking that it's approximately normal, or thinking back to what we did with our very first hypothesis test with a one proportion z-test. But still, I think this was doable if you remembered that condition. Any questions on part A? Yeah, so ultimately it comes from that assumption that we did with the proportion test, George, like the one proportion z-test, two proportion z-test. We assume that the sample size is large enough, and we check that by doing the success failure condition. Just one of those tests is fine. All right, can I move on to letter B? Yes? Okay. All right, letter B basically says, okay, here's the standard error I've calculated for you. Show how they got it. I think someone probably knows how to do this. Does anybody remember the formula for the standard error of a proportion? Standard error for a proportion. So basically it wants us to find the standard error of p hat sub x. So the standard error of p hat sub x. Not a t-test, right? Not t. We're proportions. No t's.
The one where you don't square root, right?
It's a big square root,
Yeah.
and it is a fraction. What's in the numerator?
The bottom is the sample size, right?
The bottom is the sample size.
And then the top is the expected.
It's p and q. So in this case, it'll be p hat x.
See where it goes.
I mean, now, what I think will be helpful is you'll have this formula sheet on the test.
How was it?
That's what I'm going to show you right now. If you just give me a second. Like, basically, did somebody really just count one? That's the number of goals Barcelona came up short on. Okay, so this one here.
This line.
Yes, okay. In theory, you're right.
This line.
It's right here. We just didn't use 1 minus p. We always use q. That's my preference. So the formula is given to you. Bless you. And we use standard error because we don't know the population proportion. All right, so we're using a sample proportion, which is why we have standard error and p hats. Okay, so from the problem, what is p hat sub x? What is p hat sub x? So this is the probability of success in our sample. So how many it's light bulbs, right? How many light bulbs total? How many total brand name light bulbs? 400. And how many were defective? 44. So again, I know that's weird, but the defective is the success. Okay? So what is that? What is 44 over 400? 0.11 is correct. So if this is going to replace p hat sub x, what is q hat sub x? 0.89, because it's 1 minus that. Is everyone good there? I definitely think, I don't know, I don't get to see exactly what my students do on the test, but I would hope that a few of my students from last year would have gotten this one. So 0.11 times 0.89 in the numerator over 400. All right, so now would be the time to use your Inspire or to use your yellow calculator. And we're hoping that when you do this, it already gave us the answer, did it not? What was the answer it gave?
0.015.
So let's see if you guys can confirm.
Wait,
Yes.
so when is it that you pull?
You only pool when you're doing proportions. I think PP. Yes, but pooling would be multiple groups, and we don't have multiple groups right now. 2 proportion z-test is when you would pool. Right, because remember when we did that, we assumed that there was no difference in the 2 groups, so we just lumped them all together. Z-test for proportions. T-test for the averages / means, whatever you want to, word you want to use. Say it again? Well, there's distributions. You have the normal model as a distribution. You have the T model, which is a distribution.
I'm talking about for yesterday. No, I'm talking about intervals.
Intervals. Oh, so when you're talking about confidence intervals, right? Again, if you're doing proportions, it should be Z intervals. For mean, should be T intervals. Chi-squared has its own distribution, right? Remember, that's where you have chi-squared. It has like that skewness a little bit. Or that's chi-squared. That's only for categorical variables. And then the last thing you learned in this class was to use linear regression t-tests or t-intervals. And that's always about slopes. Always, it's quantitative, always about slopes. And the Kahoot we did yesterday, we'll do again next week, when everyone's here. Like Wednesday. Everyone's here on Wednesday next week, right? Awesome. Okay, so did you guys confirm that it's 0.0156?
Yeah.
Yes. Excellent. Thank you for doing that. Appreciate it. All right, so let's move on to part C. I think this is hard. When I read this first, I was like, what do they want me to do? What do they, that's what they want me to do. I've never phrased, you've done this. What's crazy is you've done this, but I've never phrased it like this. And now that I've seen this, I'm going to phrase it like this from time to time next year. How many standard errors is the observed value of p hat x from 0.1? Well, we just calculated standard error, 0.0156. But all this is like, this is screaming at you to do something. Kind of, I think you're on the right track, Nadia. It's screaming at you to standardize. Do you remember that? So it's screaming at you to standardize. So write that to the side. And whenever you hear the word standardize in a stats course, that means to find a z-score. Now, when we did z-scores in the first semester, it was all about finding how many standard deviations away our value is from the mean. All right, that's a z-score. So when this question says, how many standard errors away is our value from 0.10, it's asking you to find, I mean, we're not calling it a z-score yet, because standard errors, we would use standard deviation, but ultimately this question is saying standardize. All right, do you remember the formula for standardization? Here's what it is on the formula sheet. Here's the formula sheet. Standardize. Well, that could, I think you're thinking residual from, you're good, from linear regression. So this is what's going to be on the formula sheet. So when I write this down for my problem, I'm writing down, and we can write z, let's go and do it, equals p hat sub x minus p sub x over the standard error of p hat sub x. And we just calculated that. So George, he already saw in his brain that we just calculated the standard error is 0. And by we, I mean they did, right? They gave it to us. We confirmed it. Now, what is p hat sub x? We did calculate this. What is p hat sub x? 0.11 minus, what do we think is the population proportion for defective bulbs in our brand name bulbs? I think it's 0.10, right? 0.1?
Why does it say p hat of x from 0.10?
Basically, I'm saying, I'm calling it this. They don't want to go that far yet. They're going to later in the problem. But I'm saying I think that the proportion of all brand name light bulbs that are defective is 10%. All right? So all we're doing is standardizing. Subtracting our statistic minus our parameter over the standard deviation. All right? Which you guys did in October. All right? So again, I think this is a really hard question, but you have done it. All right, so what is this? What is all of this? 0.641. I have my notes. Confirmed? Let's see if me 2 hours ago agrees. Yes! So it's 0.641 or 64 standard errors from 0.1. So it's not that far away, right? 0.64 standard errors is pretty close.
Is that like having oh wait, no.
Okay.
I was thinking of like p-values, like whenever it's like super small.
Don't worry, we're getting there, right? I mean, this problem is massive. All right, it covers a lot of stuff. So we're coming to p-value. It's coming. Okay, you guys ready to continue? Let's keep going. Part D. I want to give you a little time to read Part D. Go for it. If you're listening at home, don't worry, we're coming back. Start doing it. Yeah, start doing it. I want to see what you do. Start doing it. If you read it and you're like, all right, I think I know what to do, start doing it. See if it's right. You're going to have to do this soon. So give it a go. I think we all can do Roman numeral 1. Roman numeral 2 is a little tougher. Okay, so here's what it says for numeral 1. It says to basically estimate capital letter D, all right, which takes your p sub x and p sub y, the proportions of your brand name ones that are defective and your generic ones for p sub y, and divides them by 2, finds the average. All right, we don't know what these are, right? We don't know what the population proportions for these are, but we have samples. We have 2 samples. We already calculated p hat sub x was 0.11. So how am I going to calculate p hat sub y? I think they did another 400 for generic. And how many generic bulbs were defective?
104.
104. So what is p hat sub y? 0.26. So if we're estimating the letter D with D hat, right? Ultimately, that's what we're doing. We're estimating D by using D hat. What am I going to use for P sub X and P sub Y? The hat of those, the samples. All right, so we're going to use the sample proportion, P hat sub X, which we already used earlier in this problem. We just calculated P hat sub Y. We're going to add them together and divide by 2 to find the average. All right, so that means it's going to be 0.11 plus 0.26 over 2. If somebody put 2 hat, I don't know. I'm not sure. All right, so what is that answer? That is right. So the answer is 0.185. So the manager who's overseeing this operation, is expecting, if we were to pool them, right? Do you see what's happening? And this is just pooling them. We're expecting almost 20% of all bulbs to be defective. And if I'm a manager of this place, I'm like, that's too high. Yeah. Probably wouldn't use those words, but yes. You say bad lighting?
I wouldn't buy those 5 bulbs.
Fair enough. Okay, everybody okay with Roman numeral 1? I think this one was harder, but I think you could do this one. I think Roman numeral 2 is where I'm going to have my most trouble keeping you with me. So I'm going to give it a go. See how it goes. Oh, look at that. In 20 minutes with no air, it goes from 70 to 76 degrees in air. It's craziness. Thank you, air conditioning. Okay. Let's try Roman numeral 2. Roman numeral 2 says to solve for the standard error of d hat. All right? Now, I know it says standard error, but you guys know standard error is really just what? No? No. Before we did standard error, we did something else before it. Why is it? Thank you, Nadia. It's standard deviation. Standard error is just another way to say standard deviation when we don't know the population parameters. Okay? We know nothing about the population. We know samples, so we use our sample data to calculate things. That's why we call it standard error, not standard deviation. But really, when you read standard error, you should be thinking standard deviation. It wants me to find the standard deviation for D, in essence, D hat. All right? And did you guys remember reading up here that D is going to be taking the two of these, piece of X and piece of Y, and averaging them. So adding them together and dividing by 2. And it tells us that X and Y are independent. So I'm trying to get you there. There was something that's tattooed on my body. Variances add. That's what this problem is asking you to do. So Roman numeral 2 is variances add. All right, now here's where it gets a little tricky. So we've got the variance for, the standard error for the first one. You got to flip back, you should find it. The standard error of D hat is going to be the standard error of P hat sub X plus the standard error of P hat sub Y divided by 2. So, does anybody remember what the standard error from the previous part of the problem was? They gave it to us. Of P hat sub X, it was 0.0156. Yes? Now, again, do I want to use the standard error? No, because I want to use the variance. So what do I have to do to this value? No. This is standard deviation. I want variance. What do I have to do? You square it. So I need to square it. Okay? Have we calculated yet the standard error of P hat sub Y? Did they give it to us? Thanks, problem.
Yeah.
What is it?
0.0219.
0.0219. Perfect. Thank you. And again, if this is what we would call the standard deviation, I want to do the variance here, so I'm going to square that too. Now, here's where it gets a little tricky. I might lose you. When I divide, because we're talking about variances, I'm not dividing by 2. What am I going to divide by? Very good. No, it's actually the other way. You're good. It's actually going to be 4, because I got to square that also.
Square the whole thing.
If we just squared the whole thing, everything got squared. Right? But again, what I just wrote there, all of this is called what? Variance. This is the variance. Right? This is variances add. So when I do all this in my calculator, what do I have to do at the very end? Take the square root of it.
So when did that cancel?
No, because you're going to do the square root at the end.
Oh.
Yeah.
Before the test, can you make a list of
Easy. None. You mean like all the things that I would... Okay. Yeah, I guess I could. Like the 68, 95, 99.7 rule. Do you remember that one? That one takes up like this side. Okay. What's another one that I've said? Linear regression, A plus BX.
60, 90.
That's geometry?
I'm never good at more.
Ah, shape, center, spread. Very good, Kevin. I guess Nicole was the one who said it. Shape, center, spread, direction, form, strength. Yes. Yeah, I can do that. Make a kind of like a, yeah, these are the things in my brain that I just know that are rattling around up there. Okay. So this is the standard error of, I believe it's called D hat.
0.134.
You did it all? Thanks, George. That was really nice of you to do that while we were talking. Why do I have two equal signs? I'm so stupid. Okay. Equals. This is really equals. All right, so what is it?
0.134.
0.134. Let me confirm. With me 3 hours ago. I got 0.0134. It could be me. Do it again, George. You confirm with George? With me, okay. Sorry, George. You got that? Okay, sorry, George. It's because your square root is not around the... Oh, wait. Interesting.
Yeah, right. It's right.
Yeah, it's because you told me 0.134, but it's 0.0134. You have the right answer. You just said the wrong thing. Dude, I got two equal signs. You got problems with your decimals. We got a lot of issues up in the front.
It's been a long day.
Has it? It's 1:48.
I woke up at 5.
Yeah, the day is not and
Okay, let's keep going. I'm sorry. We're almost there. We're almost done with my class. So that means you're done. Okay. The last two Roman numerals. I told you guys, they told you that this is going to be a 25-minute question. This one question is worth 25% of your free response score. It is a lot, yes. So you got to do it, right? Don't just roll up there and be like, I'm not doing it. Good luck. Got to do it. Got to try. Okay. I think we can do part E quickly. It gives us the formula to use. Basically, it says, hey, all the work you just did in part D, now calculate this other variable, W, that we're defining as D hat minus 0.10, which would be D, over the standard deviation of D hat, which we're going to use as standard error. All right, so I've got it here, part E. So we're finding W, which is equal to D hat minus 0.10, or D, divided by the standard error of D hat. Guys, we already have all this stuff. We calculated D hat in Roman numeral 1. I believe it was 0.185. And we're subtracting from D, or 0.10. And then we just calculated the standard error of D hat, which was 0.0134, I think. Did I forget it? Yeah. All right, so what is W? Now, what's nice about these questions, guys, while you're typing in and writing, is if you mess up, like say you made a mistake, like say George wrote down 0.134 for part Roman numeral 2, right? So George is going to look back and write down 0.134. He's going to get he's going to get marked off for Roman numeral 2, but he's not going to get marked off for E and then for F, because what we use in E and F is coming from part D. So that's really nice about the AP exam is you're not going to get double marked. Yeah. Now, if you put two answers and one of them is right and one of them is wrong, they're going to choose to grade the wrong one. So that is where they're not nice. But they want you to pick an answer. So if you're writing down on a free response question, whether it's the investigative task or 1 through 5, and you're like, oh, I don't know if I should write this or write that, pick one and go with it. No, just cross out the one you don't want to, don't even write the other one. Okay? And if you make a mistake and you're like, oh, I don't want to do any of that, don't erase, don't waste time, just cross it out. They will not read it if it's crossed out. Okay? 6.34 or 3. Okay. How's everybody doing? We're almost there. I know, this is really tough. This is tough. It's tough stuff here. All right, let's go to the last part, part F. Now, this is where... That's how you pronounce it, actually. This is where stats teachers, when they introduce this idea of an investigative task, because, me being old, when I took this exam in 2003, that's right, 2003, I know, we didn't have this. We didn't have an investigative task. Just a few more days. Almost there. Not worth it. Not worth it. 97, I think. 1997. I think it's 1997. I want to say. So when I took it, it was not even 10 years old, I think. So you guys are taking it more like in 20, 25 years old. 22 years old. Yeah, I mean, it's getting there. Okay, so this is why some stat teachers are not a fan of this. Chebyshev would be an intermediate or upper level course in college.
What's Chebyshev?
He's a statistician from Russia. He's done a lot of work. This is just one thing. So this is where you get a lot of pushback from stat teachers where you're like, why is this on this test? This is an intro course, intro test. Why is this here? Well, it's here. So let's talk about it. Okay? So, no, you just cross it off. That is not what I said. I said if you write down stuff you don't want to be graded, just cross it out.
Exactly.
You didn't write anything down. You don't need to cross out something that's blank. Okay, so let me see if I can walk you through this. They've given you this little formula here. 1 minus 1 over k squared. All right, now k, if you look back at the problem drawing, k is the standard errors, and we just computed that in part E. We're saying that our estimate for d hat of 0.185 is 6.34 standard errors away from 0.1. Again, I know it's weird to say standard errors, but all we're doing is talking about standardization, right? Standard deviations. We just use standard error because we don't know anything about the population. It's all from samples. Okay? I know some of you are like, oh my gosh, just be done. I'm almost done. All right? Excellent. So let's plug in for K our answer for part E. 1 minus 1 over 6.34 squared. Let's get that as an answer. So Luis is saying 0.975. Anyone confirm with Luis? What's up, Mara?
What did you say?
He said 0.975. What's up, Myra? A fraction if you get control division sign. Control division. Bingo, bango, bongo. I'm glad I showed you that. That will not be on my tattoos list. Okay, let me see if I can earn my money today. I mean, I showed up, so yeah. All right, anyway. We're saying that there is 97.5% chance to observe a value for d hat. I'm going to write hat, but you can write, with the actual hat or the hat. That is that within 6.34 standard errors, bless you, of 0.10. Okay, I'm going to try. All right, while you're writing, I'm going to try. Chebyshev's formula that he gave us is saying that if we observe a value that is 6.34 standard errors away from the average, from the mean of 0.1, then there's a 97.5% chance that we would observe that value being within 0 to 6.34 standard errors. So like being right at the mean or all the way up until 6.34 standard errors away. All right? Now I'm going to try to harken back to the first time we ever discussed p-value. All right? And I'll include this on the tattoos thing, even though it'd be a long tattoo. Okay? A lot of money. Be like a sleeve. Okay. A p-value is a conditional probability. Right? This isn't just like for this problem. This is like for the test. This will definitely be on the test. The p-value is a conditional probability. You assume that the null hypothesis is your best idea of what's going on. If you assume that to be the case, then the likelihood that you observe your sample statistics that you've calculated in the problem, all right, or something more extreme, is your p-value. All right, which is why I've always said if your p-value is tiny or close to 0, then what we say is, hey, it's not really likely that I would have observed this sample statistic. So what's more likely is happening is the null hypothesis is wrong. All right? Now, all of that I just said, we have talked about. So there's a couple of phrases in there that I said that I'm going to relate back to this. I said the p-value is observing something that is your sample statistic or something more extreme. Look at the word I wrote here. Within 6.34 standard errors. So if I wanted to go past 6.34, so something more extreme, I need to do something to this number. I need to take this number away from 1. Because I want the flip side of this. I don't want within 6.34. I want something that's more extreme than 6.34. So what is 1 minus 0.975? 0.025. So this is what I think the p-value would be. All right? So if I think the p-value is 0.025, what alpha do they want me to use in letter F? They want me to use an alpha of 0.05. Now everyone should be able to do this. Compare your p-value of 0.025 to your alpha. It's below it. George, what should we do if our p-value is below alpha? That was a lot of Georges. We should reject. All right, so because my p-value of 0.025 is below my alpha level of 0.05, I am going to reject the null hypothesis. Now that's a great statement, but is that done? No, why not? Context. So this is where I would just say use the test. Go back up to the null hypotheses that they gave you above letter E. If we think that the null hypothesis is wrong, we're going to reject it. I'm going to say there is enough evidence. No, when you reject the null, that means there's enough evidence to say that the average proportion of all light bulbs that are bulbs that are, did I misspell bulbs? Oh, they want me to make it 2 words. I'm not gonna. That are defective is greater than 0.10. Whew. Okay. That is called the investigative task. The purpose of today was not to scare you, even though I think that some of you are scared now. It wasn't. The purpose of today was to show you what one looks like and to recognize that there are some things that you can do. Even if you read the question, you're like, oh my gosh, I don't know what to do. Try something. If you leave it blank, you're for sure going to get nothing. All right? And especially, like, you see how a lot of this was building one on the other? So if you're like, I don't know what the standard error of D hat is, just make it up. 0.1. All right? 0.2. I don't care. Make up. Use your favorite number. 7. I don't care. Use a number and then do the next part with those made-up numbers. They'll give you some credit. They will. All right? If you do something that is correct. Okay? Well, that was the goal of today. Tomorrow, the plan is to do Kahoots. All right, that's the plan for tomorrow. Kahoots. Tomorrow and Friday. All right. Everybody good? Any questions?
Is this another method of solving for?
It is. It's a method that you would do if you took an upper level stats class in college.
So technically, we could still do as long as we kind of standard deviation and all of that.
You could, but I think it would take you more time. I think it's easier just to use the Inspire.
This way